Good evening, everyone. Today is August 6, 2023. Welcome to MyWebUniversity free education videos. I'm going to just have a video today that is about compilers and interpreters. Without further ado, let's get started. I'm going to go through a slideshow here. So as you can see here, we're going to discuss a Linux how-tos on compilers and interpreters. And today I'm going to cover Ubuntu Linux with compilers and interpreters. This is video number 13, and my name is Wahid Lutfi. I'm going to be presenting you all the information about compilers and interpreters, what you need to know about compilers and what you need to know about interpreters. And then that's all in the platform of Debian version of Linux, which is Ubuntu distribution. And then the distribution is Debian, and the Linux flavor is Ubuntu. The video number 13-2 would be Rocky Linux, and video 13 number 3 would be Red Hat. Or 13-2 would be Red Hat, and 13.3 would be Rocky. Either way, I will just cover those two next. Today, I'm going to cover Ubuntu. So let's get started with the comparison between compilers and interpreters. So what is compilers? Or what is a compiler? A compiler is a special program that translates a programming language such as C, Java, C++, or whatever programming language that you're compiling. You're going to get a source code and then compile it into machine code or bytecode using the compiler. So a compiler is a special program that translates a programming language, the source code, into machine code or bytecode or another programming language. Another programming language in this case would be just maybe converted to native C, and then it still gets a assembler or executable files at the end of it. So what is interpreter? An interpreter is a special program that can analyze and execute a program line by line. So the difference between a compiler, which is taking the entire source code of a program such as C, C++, Java, Go language, all of those programming language that we are going to discuss, you're going to get the source code. The source code is is not machine code. It is source code is written in ASCII text in some kind of IDE or some kind of editor that you use. You write the source code and then you compile it using the compiler for that programming language. And then you just compile it all at once. So if the source is 1 page of source code, or 10 pages, or 1,000 pages, or a lot of programs together, you still are going to use maybe make to build the sources from all the sources into executables. And then once you compile it, then at that time, if there's a syntax error at compile time, it is going to just have issues and giving you syntax. But if it has semantic errors, like whatever is the compilation at the time, it will not be caught at the compile time, then it runs at runtime. Once you execute it, then you will see what the output you're expecting is not there. Then you have to look at the logic of it. Okay, semantic has to do with meaning. But syntax is sometimes you're missing a semicolon, or you're using a print statement or print line statement. Either the function doesn't exist, or you wrote it in uppercase, lowercase, or combination. Those are syntax error. And then semantic has to do, for example, comparison, when you meant to do a double equal sign and you just wrote 1 equal sign. And instead of the comparison statement of 2 Boolean expression, or a Boolean expression that this has to operand, then the operator that you're using, instead of using double equal sign or triple equal sign, you meant to do that one and you forgot, you just used 1 equal sign. And that's an assignment statement, which assigns the right parameter to the left parameter. So that is the right operand to the left operand. So in this case, compiled programming language, or always getting the source code, compile into machine code or object files or bytecode. And then from that one, if you're talking about Java programming, for example, the bytecode, you create from a .class file, some sort of object file, and then the bytecode, and then you use the Java virtual machine and to run it at the time of runtime. You need a Java virtual machine. Javac would be the compile time, and Java would be the one that you run it. And then in terms of the interpreters, since you're not using the compile, each line of the code is going to be checked by the interpreter line by line, one at a time, from top to the bottom. It's going to check if there's a syntax error, it is going to fail there. If it is not a syntax error, it goes to the next line, and then third line, fourth line, until the entire program finish. Then you will see the output of all of those ones. At the same time, if you see a line that is executing, if the line is asking for another input or something, you on the interpreter has to execute that line in order to just give you the output. So one line is going to be analyzed and get executed, and then that goes to the next line. So what are the example of compilers? Compilers, we have a lot of programming languages. We have assembly, which you're going to use assembly or NASM. I missed the N in front of the assembly, so let me correct that one quickly. You just put NASM here, and that is there, and then you also use AS for assembly, and also loader for loader to load it, and I'll show you the examples at the demo section here. So let me just go back to the slideshow. I'm going to do from the current. What are example of compilers? And the example of compilers in this case is assembly, which is NASM or AS for assembler, and then loader is at the time you link the object file to create the executable file. That's what you use. And then C and C++, GNU C collection compilers is GCC, and then you have also the GCC for C compiler, and G++ for C++ compiler. Then you also have IDE for integrated development environments, and there's a lot of them. I mentioned some of them here. Visual Studio Code is here. Visual Studio Code is the lightweight for the Visual Studio Code that Microsoft Visual Studio Code has it, and then Visual Studio Code is VS Code is also there. JetBrains is another one that provides PyCharm and a lot of other programming languages similar for programming as well as interpreters. Xcode is the Apple version of IDE that allows you to do programming languages like C, C++, Python, Swift, all of those ones. And CodeBlock is another one that is open source also, that you can get it free download, that allows it to use as IDE. And with CodeBlock, you can do C, C++, and everything else. Rust is another very powerful programming languages. Similar to C, C++, Rust is an alternative to C++ because it has better memory management and better kind of memory leak on the in comparison to C++. Rust is also, the compiler is called rustc. Normally on a Linux, Ubuntu, or on a version, it does not come by default. You have to install it, and then I'll show you some of those ones as well. And then Rust is very efficient. It's for game programming. Normally you write the code either in assembly or C++. A lot of the game programming languages were written in C++. People still use C++ for game programming, and Rust is another alternative for game programming for in comparison to C++. Rust is also very good for that. And Java is a very powerful programming language. It's the first object-oriented programming language that was introduced by a Sun Microsystem company, and then Java object-oriented. They were already there. Even when I was doing my master's degree, I was taking object-oriented programming. C++ is object-oriented programming. And then there's a lot of object-oriented programming languages. Python does both functional programming as well as object-oriented programming. In terms of the bytecode, Java uses a bytecode that is not the machine code, but it uses Java. So when you compile a Java program, you get the source code and you compile it with javac, then you create a .class file, and then you use Java and the virtual machine to run that class file, and you get the output at runtime. So Java codes are kind of write it once and run it as many times as you want on different platforms. So I need a processor that you have the Java compiler, which is you write the code that the source code, you compile it once, then you have the class file, and on the next machine that you go there, you don't need to just recompile it. You just have Java virtual machine, and you give it to the Java virtual machine, the bytecode, and it executes it for you. But however, on C and C++, whatever machine that you wrote the source code, you have to compile it on that machine. If it's x86 versus like Apple versus Spark architecture versus any other architecture, so you just run it and then compile it there and execute it there. You cannot just portability is only available if you have the compiler on the given processor. So you have to compile it again, moving it from one source code to another one. And in the case of interpreters, most of them, all you need is the interpreter itself on the given machine. You don't compile them. So the Go language is also Go, and then also called Golang. And then GoDoc is for documentation. When you install Golang, you get Go and Golang and GoDoc. The compiler is called Go. It's written by Google. That's why it's called Go. And then the three pioneers that wrote Go language in 2007 were Robert and Ken Thompson. Ken Thompson originally wrote the Unix AT&T version with Dennis Ritchie, and the C programmer that he actually wrote the AT&T version of Unix on the Bell Laboratory, and his name was Dennis Ritchie, God bless him. And Ken Thompson was also a developer. Brian Kernighan was also a developer on the C. And then Brian is still doing awk in some C programming as well. But Ken Thompson is doing Go language. God bless Dennis Ritchie passed away, the C developer here. And so we're talking about Fortran compilers also. Fortran is very good for scientific computation programming languages that we use, as Fortran is one of them. Obviously, C++ is also used for it, in Java and Python and other ones. C and every other R language is used on the interpreter. So there's a lot of them. But Fortran also, Intel Fortran compilers, we use it at Jet Propulsion NASA a lot, and then Fortran and C++ and C, or just Java, and then a lot of them, including Rust and C and Python, and they are used at Jet Propulsion Laboratory NASA, where I work at. Ada, it was the first programming language that was done by the first programmer, who was also, her name was Ada. Pascal is a programming language that I used first in my first programming language in college when I was doing computer science at City College of New York. I started City College of New York first as a freshman in 1987 September, and then that fall season I was taking a Pascal programming language, and then I took the second Pascal programming language. I really liked it. It was very good. It's a compiled language, and it was very good for learning. Pascal and C and C, or basically the mother of all languages, is very structured. You can learn. Ada is similar, but Pascal and C, is very, very popular, especially C. Every programming language, whether it's C++, Python, Rust, Java, any of them, either written on NC as a startup or has borrowed some of the syntax and semantic or kind of concept. C is not object-oriented, but C++ is. And then a lot of the programming language like Java is object-oriented. A lot of programming is either a functional programming or object-oriented. So Go language is both functional and object-oriented. It supports both, and then Go is very much like the power of C with the ease of use of Python. That's how Go language is. And then if you look at COBOL, Common Object Business, Common Business Object Language, or something that it was called. This one is back in '90. That was very famous for business programming language, and then there was Visual Basic and other ones that are no longer being used as much. But Lisp is also object-oriented programming that I was taking it either on my undergraduate or master degree program. I took a lot of these courses. Some of these courses are provided at the time at the school. Sometimes some of them did not exist back then in 1994 or 97 when I did my master degree. So Swift and Objective-C. Swift is mostly used in Apple software, but it is on the Windows as well as on Linux. Objective-C was very good programming language that is kind of phasing out because of some concept that it is not as much used as those ones on the top. As you can see, some of these coloring, I wrote the one that are in dark red, or mostly the hot stuff that everybody, like for example, for assembly, everybody that wants to write machine code instruction to be very fast, efficient for device driver, another one, even the Unix device drivers are written in assembly language. So a lot of the game programming are written C++ and assembly and Rust. So those are very hot. And then the IDEs that are there is very hot now in the market, Go language and everything. The one that are kind of phasing out, Ada, Pascal, COBOL, Lisp, and then Objective or C and Swift, I just put it in a different color. And then we're talking about interpreters. Interpreters, since it runs line by line, you need an interpreter on the operating system that you run. For example, if you want to write a Python script, you just have to have the Python interpreter. The IPython, interactive Python, is also allow you to do interactive Python, as well as the Python itself allows you to do everything that IPython does and Jupyter Lab does. But sometimes the IPython and Jupyter Lab has some kind of aliases, some kind of macros that are not provided in the Python, and you can just do those ones for ease of use. People created in an interactive Python, Jupyter Lab, and Jupyter Notebook. Those are there. In the integrated development environment, there's a lot of them. I just mentioned here PyCharm for Python, Visual Studio Code that you can use C, C++, Python, and every other language. You just have to go to the extension and install the extension, and then either use the interpreter or the compiler to compile it, similar to other ones. JavaScript is kind of on the browser side. JavaScript, CSS, cascaded style sheet, and hypertext transfer markup language, HTML, or all kind of like browser side scripting that allows you to run some code on the browser side. PHP also runs inside the browser as well as the server side. PHP stands for Professional Homepage. This is very good for programming. The syntax is much like C, so it's very easy to learn. Ruby is another good for the web programming that allows you to do it. Python is also general purpose programming, as well as functional programming, as well as object-oriented programming. So a lot of these things for kind of statistic software, for some sort of artificial intelligence, for data science, Python would be the choice that you use, or JavaScript, or maybe R language, depending on what you're doing. Awk programming is Brian Kernighan was one of the Awk developers, and there were 3 of them. They just came out with this abbreviation for 3 names. Please watch my other videos on Awk and other ones. And so I have explained all the details of them. For Bourne Shell, and Brian Kernighan was the K for his name. Bourne Shell, Corn Shell, Bash, C Shell, True C Shell, and ZSH are all examples of shell scripting. They're all interpreters. And then at the time that you're writing Bourne Shell, the interpreter for all of these ones in lowercase. So I did not put it between the brackets like what they're the interpreter for them, because you would know that it's lowercase. Unix is case sensitive, so there's no uppercase as such. You may create a variable, but and the interpreter itself is Bourne Shell, it's lowercase sh. Corn Shell is KSH. Bash, Born Again Shell. C Shell is the C-like syntax for shell. And then True C Shell is the enhanced version of C Shell. The ZSH is a superset of all these shells that's in front of it, and it supports all kind of features that is supported in Bash and True C Shell. And Bash is a superset of SH and Corn Shell, and True C Shell is a superset of C Shell. So ZSH is a superset of True C Shell and Bash. That way it has some more features with graphic and coloring and everything else. So you have all of that. And Perl is a practical extraction reporting language. Back in 2000, this was the choice of web programming, but CGI programming. I was using it for my web university, and I converted all of that to Python programming. And Python is very, very much efficient, very simple to use, and very object-oriented. And it's it just took the market out of Perl in every way. So Perl is not as much used. Every programmer has already migrated to Python. I'm one of them also. And then we're gonna just go to the next page. And the next page is demo section on Ubuntu, which we're gonna show compilers and interpreters. So without further ado, I'm going to now jump into a Linux Ubuntu server, and I'm going to show you all these compilers and interpreters that we talked about. Okay, so let's get to that one. And I'm going to show you, I already been running my Web University, running the virtual machine here. So let me just log in here. Currently, I'm trying to log in, and that password work. So on the screen, that is this one that you see here. Let me just get out of this directory. So I'm going to say host name here, and then say host name CPL, and then you can see that I'm on a virtual box here. The virtual box, my Web University that I just showed you, that I come in here on this one, my Web University. When you say show, this is the host name here, and this is a virtual machine VM that I'm running as Linux Ubuntu. And if I say cat minus etc os-release, you can see that it's showing on line 4, it says version 22.04, long-term support. The code name is Jammy Jellyfish. As you can see, this is the same as in the MyWebUniversity, the host name there. So clearing the screen here, host name is MyWebUniversity, host name CTL is that, and cat etc. Let me just say, this one is os-release. We did that one, clear the screen, ls etc star release. And then on the Linux Ubuntu, there's a file called LSB, Linux, whatever that stands for, I forgot, but you can say man lsb dash release. There's a file for it. No, what is lsb dash release? It is nothing appropriate, but you can cat that file etc lsb dash release, and it just shows you the version, the distributed version, which is a release of a distributed version, Linux server base release or something like that. That is what it stands for. Man LSB is not there either. So if that information is not there, don't worry about it, because you can just say cat etc lsb release, and it just says the release is 22.04, and the name of the description is Ubuntu 22.04.2 long-term support. But this is again on my local machine, the local VM. So how do I know that one? ID-UN on this one, I'm logged on as Wahid, and then who am I? It just does not show anything, but who am I will show that I am Wahid. The reason this one does not show anything, because I log in locally. So if I say IPA, you will see the IP address of this one is coming from this local interface, which is on my virtual box. On the virtual box right here, if I go to setting and click on the network, you can see it's network address translation, NAT. That is telling me that I'm using netstat minus RN routing table, and you can see that I'm on the 10.0.2 gateway, and then the IP is coming locally from that machine. I can also get fconfig enp0s3. That interface will tell me exactly the IP address of this machine. That's local. But if I say nslookup www.mywebuniversity.com name server lookup, then since I'm trying to find out on DNS what is the IP address of that machine that I'm there, it is going to be showing MyWebUniversity is my web server, which is hosting this website. Right here, right now, it is showing my website that is running on HTTPS, and it is just basically the entire book. Everything is all available online that you can start learning. You're welcome to go there and then start learning. For example, on the chapter 4, I have a lot of good videos for chapter 4 advanced level Unix, and then all these tables of commands. I have explained it and video by video. For each row, I have one video here called video 1 of 8, and then video 2 of 8, and 3 of 8, until 8 of 8. All these ones are explained. But the reason I'm showing you mywebuniversity.com is because I mentioned here on the discussion for the virtual box, right here, I mentioned that I'm going to do the demo on a Linux Ubuntu, but I'm going to just do a lot of it on the MyWebUniversity website, that you can see how many codes I have written to make that website available online. So you see the actual application of these courses. And then right here, after you see, click on this screen and then clear the screen. I have already logged on through Secure SSH into this machine here. And remember the and this lookup was showing this IP address. So if I just go back here and say IP8, you will see that one of the IP addresses that is showing .31 is on this list, right? So the one that is actually on this machine is called Ethernet 0 is the interface. And this is the IP address here. So if I just clear the screen here, say IP Ethernet 0 or fconfig Ethernet 0, you could see that the IP address of that machine is there. So if I say host name here and then host name CTL, now notice that this one is the host name, which is right here. It says www.mywebuniversity.com. And if I just click on this one, it's going to go to the website, open Firefox, and just open it into the browser. But I have already opened it here, so I'm not going to just make you get tired of just going to the website. Let's get to the rest of this session. And if you go at the computer server here, the name of the host name is algorithm, statically host name that we did. But the transition is the actual host name is mywebuniversity.com. And let's look up www.mywebuniversity.com also tells me that it is the same IP address that I provided right here. So let me just do this. And then and let's look up and then IP fconfig Ethernet 0. And then you can see that the same IP address that's showing .231 is there. Netstat -rn also here, it tells you that, let me move this one out of the way. And you can see that the gateway and everything that is there is up and running. And then the machine is also available here. So if I just, by clearing the screen, say ping www.mywebuniversity.com, you can see that it is coming on this IP address here. And then similarly, if I Control-C out of it here, and then go on this local machine and say hostname here, and then say ping www.mywebuniversity.com, which is the .231, is going to get to that one. The other machine, if I say ping MyWebUniversity, just like that, you can see it is pinging the local interface of loopback interface, which is clearing the screen. Fconfig loopback interface is 127.0.0.1. And then here, when you do that one, it's going to show that. And the reason it is doing that one, I'm going to Control-C out of it. They say grep -i MyWebUniversity from etc host. It is because I tied it to the local interface for loopback. But the actual website that it is there, it is going to have a different name. So I'm going to get into this one, which is the actual web server. So we are on this machine, cat etc/release, and host name is MyWebUniversity, and I'm going to demo the Linux Ubuntu now. So clear the screen, pwd. I'm on this demo directory. So the first thing that I want to do is show you a script called welcome.sh, which is a shell interpreter. And that is written in either bash or sh, bourne shell. So if I just want to see the content of that file, I could say welcome more welcome.sh, and it's gonna just show me the first line is saying user ben env bash. So which env? This is a file user ben env is actually a binary executable link format. ELF format, but this one is going to be on that file, grep actually had -1 of welcome.sh. You can see the first line that says use the env to load this bash interpreter. So if I do this one and I say which bash, you can see that it says use the env to find the bash interpreter that is finding /bin bash, and then that file /bin bash is also an executable link format, but it's that bash interpreter. So my PS here shows that it's bash, and then now if I just say run the welcome.sh, welcome ls-ld welcome.sh, you saw the whole code was there. So clearing the screen here, notice a couple of things here. The name of the script is called welcome.sh, meaning this shell. You can call it .bash also, it is there. But grep minus, let's say, head -1 welcome.sh. You can see the first line that I'm doing here. This shebang, which is bang, is telling the environment variable to load bash, and then the next lines that are there on welcome.sh, that one, line 2 and all the way to line 23, it is going to look for syntax of bash interpreter. So these are commented out. You can see it is commented out, and these are, this is tput clear screen. So since I'm doing a tput clear, I could run the welcome. Actually, let me just, oh yeah, right here the file is executable. Since the file is executable, this X is set for the owner, which is W Lutfi here. The group is root, and then others is also. So everybody has execute permission. That means I can just say welcome like this, and then run the script and run the output. So what is that script supposed to do? It's going to say 3 new line characters, and then between 1 to 10 is going to keep saying that welcome to my channel, and then my channel is going to be saying welcome to my YouTube channel, and my YouTube channel is going to be listed there. So this is basically that line, and because cat -n welcome.sh, and since that line has this laugh out loud utility, it is going to change it with different colors every time it runs. And then notice that the module, it has a syntax of if statement. If the color on this part, if the code is going to check if the number is even, so the number module 2 is equal 0, then it's going to just print a white color. Otherwise, it's going to do a color coded information. So welcome. You can see that it is actually for even, it is a white color. Yeah, for even is white. Otherwise, it's going to be all this color. And then the nice thing about that laugh out loud command, every time you run, you get a different set of colors. You can run it as many times, and as many times you might get a different set of colors for that one. Okay, so this is the welcome on the sh. I'm going to later on go to a lot of the interpreters as well. I have already made a lot of videos for video number 10, 11, and 12 was shell scripting, but I'm going to cover a lot more in other ones. So I'm going to jump in to other ones because there's not time for covering just the shell scripting on the entire video. So I'm going to cover something now on the basically in order for me to just do this section, I'm going to start with the interpreter first, demo on the interpreter, since I already did the shells, and then I jump into the compilers next. So in order to do the interpreters, let's do the shells first. And then on each one of them that I do interpreter, I go, for example, I say banner interpreter. And then you can see the E is missing here. And that is not giving you there. And then the nice thing about this banner itself, you can just abbreviate it to 2, and it will just say interpreter. Like that, you can do that one. Or clear the screen and say show fake fonts. If it is there, all the fonts that we have, let is a command line that you can do all these kind of fonts. So you can do dash B for bake or dash C for block or bubbles. Well, let's do bubble. Let's do bubbles, and we say piglet minus C for center minus F for font bubble. And then the text we want to print it is called interpreter. And then that's how it prints it there. So clearing the screen, it does this. And then the nice thing about this one, if you want to just print that one with each of the show fake fonts, let's just write a script quickly on the fly to do this one. Show fake fonts give you all the fonts, right? And then the fonts, notice is the name of the fonts is here with colon. So if I just say show fake fonts and then grep colon, then I get all the fonts here. Now, if I want to get the name of the fonts only, not colon, say awk or cut, I could do awk, since I'm going to show you awk programming language, $1. So that it's separated by space there. So $1 would print me only the name of the fonts. So if I do this, it gets it. If I want to use cat command minus D delimiter, and then I could say the delimiter is this minus F1. That would also give me the name of the font. So whichever method you prefer, let's do the first one with the awk print, since we're going to later on cover awk. And then I'm going to say while read var, and then I'm going to say do. At this time, I'm going to say piglet minus C for center minus font, and then $sign var, the variable, and then I'm going to write interpreter here. And then just say done. And for all of them, on all programming languages, I mean fonts, it just wrote the interpreter. Whether it made sense or not, and notice the first one with the banner, this one it wrote it the way we want it. Interpreter here and all the fonts, it is printed with bubbles and the scripts and all those other syntax. Okay, so that is good that we did that one for the command line. And then now let's do just write something with a sh. So my current shell is bash. If I want to just say write hello world, I could say hello world. This is interactive bash. So I could do this one and it will just write hello world here. And if I want to say for item or I in sequence of 10 times, let's say we want to just write say do echo hello world, you could do that one 10 times and it say done, it will just do that one. But then if you want to just use some kind of utility with this one, loud cat command, then you could get different colors there. And then now you just let me clear the screen first here. Clear the screen. If you just decided that and instead of hello world, you write hello bash for bash scripting, you could do that. And then the word string, you can do anything. Hello, ZSH, and you could do this. So now PS is there. I'm going to jump into ZSH. And ZSH, since I don't have this .zsh file, it's prompting me that, okay, on this current directory that you're doing as the user, you could just say cd, not cd actually, I could say touch, and then I'm going to run the .zsh tilde, which is my home directory .zshrc. So now my zshrc is done. So notice if I exit out of this ZSH, I'm on bash, but this time if I type in ZSH, it's not going to prompt me. It's just going to change my prompt to this, and then hostname, everything there. So I could write another one, say for item, I could wrote item, whatever, and I'm going to say $, instead of the backtick, and say sequence of 5. Let's do that smaller one, and say do, and say echo minus E, and then expression, and then we say hello, or let's just say $1 item colon hello. We could just write hello that many times, hello, and then we can even say $item to print the number 1, hello number 1, number 2, hello number 2. And then just if we want to put a new line character, we could do this because we did the minus E. And now notice that says hello 1 for 1, hello 2, number 2, and so on. So there's a lot of ways you can do that one. This is ZSH. So clearing the screen, PS, and if I just go to ZSH again, I just say PS, and then echo $, is pointing to the process ID of ZSH. And if I just say, let's say I'm going to create a variable name and say name is equal Wahidullah. I'm going to just do this one, and then last name is equal Lutfi, and then now say echo $name space $last name. That was going to say that. And if I just want to say something with it, say do like write hello space that, and it's going to say hello Wahidullah. So however you want to do it, it is not a programming language. They allow you to do this one. And if you just want to do hello world, again echo hello world, and then the hello world is there coded somehow. Let me just see why it exit. It looks like it took the code out of there. Yeah, the code was the problem. So somehow, let's see. Yeah, the code, I did not close it. So that's why that issue is happening here. So the way you do that one, when you do that code, you have to like that, you could just write it, or you could just say, since this is a new line, you could say echo hello word, and then that one, or hello and then $name, hello word, or hello Wahid Lutfi, and just take the word here out and then say hello Wahidullah. So however you want to do it is fine. And then if I just exit out of the thing, I could go on C shell. Now I'm on C shell here. And then set env name as equal Wahid. Now, sorry. Yes, I'm on a C shell. Set env. I wrote ent by accident. Name is Wahid. Now I say echo $name is going to say Wahid, and I say echo hello name $name. The name is only defined as lowercase, so you have to write it as lowercase here. It's case sensitive. I cannot write uppercase N, it's not recognized, undefined variable. But if I say set env name is equal, let's say Belgate, and then I just write a hello name that's going to say hello Belgate. So whatever name that you assign there, and that's there. So C shell and through C shell is similar. So through C shell, PS now echo $sign is pointing to through C shell. So if I just say set env age is equal 50, let's say, or 60, and then I say, I'm sorry, there's no equal sign here on that. The export will do it, but when you do set env with the C shell, there's a space rather than equal sign. Export will do equal sign. So set env now echo $name name. You could just say that like this, and you say echo hello $name $name, and then $you are $age years young. So I'm sure he's over 60, but I'm just trying to be nice. He's way overqualified for experience, so that's what it's going to say. Hello, Bill Gates, you are 60 years old, young. So the thing that you want to do here at this time, let's just say for PWD, we did it for demos. And then if I just go for C shell, we did it in true C shell. So if I say corn shell, and then now notice my corn shell syntax has changed. $sign pointing to that one. So if I say export and name in uppercase, and I'm going to assign it to Wahid, and then I say echo $sign and name, now on this shell is Wahid there, and then echo hello hello comma $sign uppercase name. Here, notice this one is going to say hello Wahid here because I'm on this corn shell. Once I exit out of this one and I run the same hello program that I did earlier, it's going to just say Belgate because echo $sign name is going to show Belgate. I'm on the different shell here. So clearing the screen here, and then clearing the screen here, and now I type in on the C shell the environment variable. You can get this environment variable here by typing env. So notice here echo $sign name uppercase is not defined here. It was actually defined with Belgate. Lowercase was name Wahid. So you could do that one, but if you just do something like uppercase N and A and lowercase and uppercase, that's not defined. So anything that's not defined, you cannot use. So now we are doing that one with this, and now the next thing I want to do is corn shell. Actually, I did corn shell, and we do bash. So bash, you could say echo hello word, and that will just print hello word there. And then I use the for statement there. At the same time, you can write a script here, and just for example, let's say when hello.bash, I could just write it, and then here I could say shebang user ben env bash. That tells that there to run, and then here's a comment say And this is the hello bash script. Hello world. Let's just say hello world. And then on here, I just say echo minus E, and then we just say hello world. And I'm gonna put 2 new line characters to just show the line characters, and now say echo, thanks for using our, thanks for watching our YouTube channel. So if I just do that one, and then right here, I'm gonna just show you the YouTube channel here. I could just create a URL, the name of the channel, which is gonna be HTTPS, and it's gonna be youtube.com/@myhandle, which is MyWebUniversity. That is the YouTube channel. And then here we'll say thank you for using our YouTube channel. And then we just put a tab here, minus E, and then we put a tab here, /T, and then we just say $, and then URL. So that URL will be printed afterward. And then on this one, I'm going to just only use one line, and right here after the new line character, I'm going to do 2 of them. You could see why. So it listed that one, and then there's differentiated between that one. So now hello.bash, it is created as a bash script. Notice the permission by default is not set to executable. That's because of this umask. The umask is going to say that whatever is the file, whenever you create it, it is going to be something like this: 0777 minus 0002, which is, this is the permission for creating a file. It is going to be 0777, meaning that whatever is the number, must subtract the umask from it, and that's gonna be 0. Then it's gonna be 5, and then sorry, 2 minus 2 is 0. Let me just do that one correctly. So 7 minus 0 is 7. No, 7. The umask is 002. Oh, for the file is not. This is for directory. It is 666. So that's the file. That's why I did not come up. So that's like 66 and 666, and then the last one is 0. Actually, 6 minus 2 is 4. So this is for the file, when you create a file. But if you create a directory, it is 70777 minus the umask, which gives you read, write, execute. And actually this one I'm going to say 775. Usually this one is the number. Let me just do this one quickly. 775. Usually this one is a read, write, execute, and read, write, execute. Usually the umask is not that number that is showing on my web servers. It's let me correct this one: read, write, execute, and read, write, execute, and then read dash execute. That is the permission for that one. And the permission for, sorry, why is it just going to all this junk? Okay. Let me go to the, oh, I'm on the command line. I thought I'm on VI. So usually the umask, the umask is 0022. So the read write execute is also read dash execute. Writable should only be writable by the group, which is safe to do 002. And then the group, if you don't want it privileged, you only give it read and execute. That's why you do that. So in this case, the file that gets created for hello.bash, it is read write, which is 6, and then read write for the others is 6, and then read only for 4. That's group permission for it. But if I say make a dir test 1, and then now I do a test 1, the permission is 775. So that is 775. Read write execute, and read dash execute, which is this. The first file, if it's a file, it has a dash here, meaning that it's a regular file. If it's a directory, it's going to be a del, D for directory. So you do a stat on the hello.bash, you can see that the statistic, it tells you that this is a regular file, and it has a dash in the first column, and then it also shows you the user ID, group ID, and all the details there with the modification time. This structure is called inode. The inode is data structure. So the stat on the test1 directory, it is a directory. And Unix, everything is a file, but notice that it says that here is a directory because of that D just identified. A directory is nothing but a file, and a directory only contains the name of the files. So that's what a directory is. I'm going to go back to the example of hello.bash. Since it is not executable, if I want to run it, it just says hello.bash is not executable. So how do I execute it? I could either do my bash -x hello.bash, and every line that I have is going to run the with the plus sign, and then it's going to give you the output below it. Or it's like this one, it set the variable, then it does the echo, and then that one. Similarly, if you don't want to get the line showing in a debug mode, you could just say change mode +x hello.bash. Now hello.bash is changed the color with to green. That means you have an executable file. So file hello.bash, it says that it's a again shell, a script that is executable. And then now if I say hello.bash, it's gonna just run the output, run the command and give me the output only. Hello world, thank you for watching our YouTube channel, HTTPS and this. So if you just cut and paste on this one and just say, okay, yeah, let me just Control C out, copy this one, copy link, and then just go here on the web server and then just paste it here. Actually, it did not come up, so I could say HTTPS youtube.com/@MyWebUniversity. I didn't foresee, so let me just do the one in English right there, and then it will go to our YouTube channel in English. Okay, I have it also in foresee to help out people that they need to be educated in my own language that I was born in Kabul, Afghanistan, and then now I've been living in the US for longer than I lived in Kabul, and I have been having a lot of videos on both languages, and I'm hoping to help everyone without any kind of concern about where you are from or anything. And this education should be free for all. So that's why I have it on both languages. Coming back to the Ubuntu Linux, here we did a bash, and then clearing the screen here. So notice that every bash script I have here, you can run it and you just get an output for it. So one of them was like for example, cut for sports.bash, and then you could just run the script for sports.bash, and you will get the output there. So whatever script that I have is whether it's .sh or .c shell or .bash, I have already covered these ones on the previous videos, and then today I showed you those ones how as well how to do hello world. The next thing is I'm going to show you awk, clear screen, which awk Brian Kinnegan was one of the developers that is still programming in C, and he works at the universities levels as a professor. So I'm going to just show you what you can do with awk. With awk, there's a lot of things you can do, but I'm going to, as an interpreter in a scripting language, it is very powerful. It give you a lot of details, but and on top of the syntax that allows you to cut and paste, like for example, if I just say, do a list of the files here, and then just say, do a list, and then awk, and then say, print $1. So $1 would give me only those files were on that on the listing. If I just say ls minus l and then get that $1, it has a different meaning. $2 would have a different name, and then $3 would have a different parameters. So each one of them, like $9 is the file names. So you could get the file names, and then if you want to do this, say do this $9 and then grep star.bash. Sorry, let me just clear in the screen. Grep star.bash, you will only get .bash here, but you don't need to do star.bash when you can. You don't need to grep out .bash when you can do this. You don't need to write this grep again here, because when you list it like that, you just get the bash script here. Except grep will do auto coloring, which is an alias for grep. You can see that it is just saying that grep with grep auto color. So when you do ls star.c shell, and then you could check on this one, and instead of the bash, you could say .c shell. And now if I want to just list those files or do a content of it, I could do cut or just say, well, read a file, and then say do stat echo working on $sign file now, and then dot, and then say sleep 2 seconds, and then say cut minus n $sign file, and then at the same time just run it, say $sign file, and then just do another sleep 2 seconds, and then go to the next one, and then do a timestamp of the time that it shows, and then just do it done. So working on this one, and then run the output, then it goes to the next one, and go to the next one, and so on. So if you want to do that one, you could just go back here and revise your code. And where I wrote the running the cat, I could say do another sleep here, sleep 2 seconds, and then say date command here again. Date command here, and then run this. But notice that this time we're going to see the actual script like there. Then we get the output, and then we get the next one, the script name, and then we get the output, and we are done with the timestamp. So there's a lot of things you can do with this. So with the awk, you can also like here, this one was a command line syntax that we did. You don't have to do command line, you could do it using a scripting language. So you could do, for example, awk, and you could say print hello world. And then let's do this one. We could say echo this hello world here, print hello world. Rather than the print, we could just say do this new line character. And then if I do this one in bash, no, sorry. If I do this one in bash, it's going to say hello world, but I don't want it this new line character. So I could do with a new line character, but I need to do a -e here. And then now, if I just produce that one, give it to awk programming language, and then say print $0. This one will print hello world, similar to the what echo was doing it. And if I just don't say $0, it still is going to do the same thing, because $0 means everything. But if I say do only $1, it's going to say hello. $2 would be a word. If I want to get both of them, I could just leave it blank, or say $0, or I could say $1, comma $2. It would print it like that too. So depending on what you're doing here. Let me just show you a couple of awk programming here. So I'm going to go to shells, actually programs. I'm going to go 3 level up. So I'm on this directory programs. Now I'm going to cd to awk. And then that is there. Let's see what I have here. I have a couple of files. One is called data file, which is used as input file. So you can use cat -n data file like that. I'm sorry, clear screen. ls -l cat data file like that, or you could say awk, and then you could say print, and then say data file. You can do the same thing here using awk there. So if I want to say, for example, hello dot text, cat hello hello dot text, that one is like my echoes things, right? So I could say cat hello dot text and say awk, and then print $0, and that would just say hello dot text. Or I could use the awk programming language, cat hello dot awk. If I want to print that file, I could just say awk, and then print $0, or you don't have to do $0, just print is good enough. And then hello.awk, it will just also do similar to the cat command. But if I want to execute it, notice this file env is running the bash interpreter. So as if I'm running this one with the output of hello.txt. So if I just say hello.awk to run it, it's going to just load the bash interpreter. It's going to use the awk and print the hello.txt, which is hello world. Whatever I wrote on the hello.txt, if I say echo hello Wahid, and I just say greater sign hello.txt. Now hello.txt is hello Wahid. I run the same command that I ran previously. Is going to say that whatever is hello.txt, and then if I just run it like this, it's going to say hello Wahid, because I dynamically changed the source file, which is the hello.txt is statically, but the program, whatever the input file comes in, it's going to produce that output here. So you get a good idea about how programming with hello. Let's look at the core demo .awk. So that one is doing a for demo. And again, if I want to print that one using awk, I could say awk print and then the name of the file is for demo.awk. It will just do like a cat command here. But if I want to run it, it says for demo.awk, it's going to just do all these values, because we're saying that for I is less than 5, do your lucky numbers. But since we are using the random function to multiply it by 64, it gets different numbers. So every time we run it, we get a different set of values. And then the next thing that we want to do is cat a data file. It is data file is 5 numbers. Now we're going to say cat while demo.awk. It's a shorter form, so I'm using cat command. And then now what this awk program does is read the data file of 5 numbers, and it prints the number and then increment I++ using a while statement. So let's run this one. To run it again, you do this, and it runs that one and prints it here. So the command sequence, as you can see, sequence 10 is going to produce 10 numbers. Sequence 100 is going to give you 100 numbers. Sequence whatever number you want to just generate it. So I'm going to do a sequence of 5 and then send it, not sequence of 5, let's do 7 greater sign to data file.txt. So now the data file is .txt. I'm going to move the data file.txt to data file. I should have created the data file. So you could have done sequence like that command here. You don't have to move it. So the data file now got created. The data file has 7 of them. So if I run the while statement this time, while demo.awk is going to just print out those numbers. So clearing the screen here, then let's just do something here. Then while demo.awk, must have typed a little bit off. So then while tab demo.awk, and then here you can see that when I'm reading the numbers, I increment it and then go through this. But while I is less than 5, so it doesn't matter what the data file is. We're only doing it for up to 5 number. So if I just say while I is less than 3, then print it and then increment it. And now run the while demo there, and you can see that it gets up to that number 7 for the demo file. Incremented there. Cat while demo.awk. It says awk I is equal 1 while I is less than 3. Print I and then I++ data file. So it reads the entire data file and then it just printed $ I is saying that just go print it, and then I++. Let's do one more thing on this awk. Actually, I'm going to do a command line awk also here. So if I just say this and I want to say let's minus cell, let's say PS minus EF rep minus I Apache. So you can see Apache is running, Apache web server is running. And then you can get information about the status of it and everything. So I'm going to do a sudo su dash just to become root first. I'm not going to stop or start any services, but I'm going to do lsof actually PS minus EFA grep minus I Apache. And then once it defines it, if I'm interested in the $2, which is process ID number of these ones, I can get a list of all the process, and if I want to stop them, or I can kill it, or can do whatever I want to do. But here's the power of awk. You could say print $2, and then you could get all the list of them. Then you could say while read a var do, and you could say echo working on process PID process ID of and $var, and then at the same time say PS minus EFA and grep that process ID, and then just to do that one only, and then say done. And notice it's for each one of them, it says grep out the first one, it goes there, and we can also do a grep out the grep itself. So like here, PS minus EFA, and then say grep minus V, the grep itself out. So it does not list it. Now it shows it for each process there. At the same time, if I want to say LSOF, LSOF, it shows all the processes that's running on the system, list of open files. LSOF SSH, clear the screen, LSOF minus I port 22 is going to be SSH there. So if I just want to say for the process ID of SSH minus P, and instead of the source, I could say, let's say, for example, 1726. Then it shows all the connection that are established, everything that are there. At the same time, I could say LSOF minus I SSH port 22, and then say grep minus I wlet3. And then it says, okay, yeah, that this is Wahid is coming from this other interface. So if I say who am I, I'm root. But if I exit out of this one and say who am I, that says wlet3, who space am I is going to show my SSH connection that remotely I'm coming from this interface. And echo $display is set for me or not set, then depending on whether I use xterm or x display or not, and how I export it. That is something that you should watch my other videos on xterm. But I'm logged on here, and I'm using SSH. So we did do a number of things with auth, and here you could do also with this command that I did here under, let's say LSOF, we did it, let's say cat etc password file. So when you do the password file, if I want to say cat etc group file, and then I want to just awk only the second interface, I could get that one, say awk minus F uppercase, and then I, instead of the space, I could say the separator is colon, etc group, and then it's gonna just I have to actually do etc group. Let me see, etc group. Yeah, etc group. So I'm going to do this, and then cut awk minus F separator this, and then let's just do a minus F, and then print it, and then at the same time etc group. Oh, and that would print the name right like this here. And if I'm just searching for a user ID here, I could do a search here also, slash let's say wlet3. the string that I'm searching for, and it's sorry, the slash might be the other. Oh yeah, slash. You have to put another slash here. It's gonna get that information. So that is the search there. So whether you do it this way or you could just say the search of awk will allow you to do that one, or you could say grep minus I double F, and then that would also pick up the same information. So there's a number of things we can do with the awk. So on the IDE, we were talking about interpreters, and it is already 11:52, and this is going to go really long. So I'm done with bash scripting, awk, and let's see, bash scripting, awk, and Perl. I'm not going to do, or I'm not going to do Ruby. I'm not going to do any example of PHP. I'm not going to do JavaScript, CSS. So I'm going to jump into Python here for the interpreter. Python, IPython, and Jupyter Lab. And then to do the demo on those ones, because those ones are, I have a lot of videos already, so you're welcome to use it. And then for Python, when you say Python dash version, it tells you what Python version you use. And if I say Python by itself, it's going to jump in to 3.8 version that I have. If I do a dir list, it's going to do this. If I say print and then say hello world, it's going to just do that one, and it's going to print it there. And then also you have exit out of here. You can also write a Python script here. Let's say clear a screen. Let's myself Python. Let me see. Yeah, I have a lot of the script here, so I'm going to demo some of them here. CD to Python. Clear the screen here. Let's do a number of them. Clear the screen. Ls. I'm going to go to the demo section to see what I have there. Maybe I have a couple of them. Maradona, the text to audio. Those are text to audio is just generated text to audio, but I'm gonna do just display because I have this video already. But maybe you should look at text to audio.py. This is basically read the file, the data file that is I provided, and then it's going to generate MP3 files for it. And so we could do that one on Windows, but I'm doing this one actually on a Linux virtual machine. We could do it, so we could do a number of things on this one also. That's there. I'll show that one as a demo and a next level because I've already done a video like that. I want to show you the shorter commands and examples here. So if we just write, let's see if I have some clear the screen, cat p1.py. Okay, that's a small line here. Hello from the Python script, and it says for item, between item to this is a number. So in order to do this one, again, shebang user ben env is loading the Python interpreter like we showed you earlier. So the Python interpreter, Python dash version or Python dash v, uppercase V, is showing 3.8. So it's going to load Python 3.8. It's going to print the hello script, and then for item and range, it's going to do that one. So if I say p1.py, it's going to just do that one. So then p1.py, if I just say for item and range of, let's just do a different thing. So we say range of 10 numbers. We could just run the same code. Now it's going to do between 0 to 9. Then p1.py, notice that interpreter, the way you do this one, we're using a for statement, but we could use another one and just say, let me just write one from scratch that you could see that how powerful Python is. So how easy it is to write code also. So I'm going to say p2.py I have or not. I don't have a p2, so I'm going to say vem p2.py. So the first thing I do is a shebang, user ben env, and then Python. Since Python 3 is coming with the word Python, it's fine. I'm going to do that one, and then I'm going to say print, and then say this is p2.py program. Just for that one, to just show you a quick thing first. So let's just run p2.py, and it's permission denied, change mode. The reason it says permission denied is p2.py is not executable. But if you say Python and then p2.py, it runs the command. And then say this is p2. But notice this is as Python 3, so it needs a left parentheses, right parentheses in it. That's why it does not understand. Python 2, you could do that one. So Python 3 does not allow it. It just says you have to use it as a function, which is left parentheses, then the code. You could use double quote or single quote. Everything is working fine. So now if I just up arrow here and run it, it says that code is running. But now I want to do more than just a simple hello world or this is a Python. So when p2.py, let's write some code to run some list, create a list. I'm going to say my list is equal. I'm going to run a few commands. Let's say we say hostname. We're going to say the list is actually a combination of hostname and uppercase, and then let's do the command id-un, and then I'm not going to do id-un. I'm going to just do let's say and let's look up google.com, and then that's two command, and then let's do one more command, say who or calendar command, just to print out the calendar command. So we do those two commands, and then now I say, and instead of this is program 2, I say for cmd and my list, and instead of my list, actually I'm going to call it commands, because that's what those commands are. It's not a list, it's a list of commands. So I'm going to say commands, or those ones. So this one I could say for this, and then say colon here, a separator, then I go 4 lines here, and I say print running the command, and then comma $CMD, and then just do that one. Now I'm gonna say let's do os.system, and then I'm gonna just run the system command first here, and then say cmd, and then that's it. And then but I need to import the OS module. Import OS module, so I could use the OS module with os.system function or method, and then run it there. Clear the screen. Cat p2.py, and then clear the screen. Cat -n p2.py. On line 1 is the shebang user ben env loads Python, and then line 3 import the OS module, so I can use os.system method, and then line 5 has the commands that I'm just having hosting and this lookup, google.com and calendar and everything. So I'm going to just run this. What is the name? Is called p2.py, and it says permission is not set. So I'm going to say change mode 755 p2.py. Now p2.py is executable. So I say p2.py, it will run, and it says file. This one is not somehow. I started with 2 double equal signs, so let's just vim it again. And then right here, I not need this code. For some reason, I had a mistype there. and then that's it. So I'm going to run the P2 again, and this time I just did that one, $ command. Since I'm not on a shell, I don't need the $. Python does not need $, but Perl does, and then Bash scripting does. And so here we're running it, this one, and it's going to run the command, and it gets the output there. And there's a number of other ways you can do the same thing. And then if I just use the Python interactive, let's do Python interactive. IPython is going to just jump into interactive. Notice here that you have a list of aliases that we did not have it. So if I just say ls, it's going to run the command. If I just say elder, it's going to run that command. If I say more, it's going to just more, if you see os-release, it's going to just show that command. And then at the same time, as aliases, we could also say ls magic. And the list of magics that are available, aside from aliases, there's cell magic and line magic. And all of these ones are available here. So notice that with cell magic, you have Perl, PRAN, Ruby, Python, Python 2, Python 3, and then JavaScript, shell script, HTML, and a lot of other ones that you can do that one. So if I jump into a Bash, I could do that one, and or I could do any of these ones with one of the percentage, like percentage who command will just say that it is their percentage who's it, as it percentage history. I will give you the history percentage. Colors, let's say colors, what does it do? Let's give you a set of colors if it was set define or something. And then at the same time, the double percentage, it's gonna jump into like a Python programming language like Python 2 that we were talking about earlier. Python 2, inside here you could say print and then say hello world, and that would just execute it hello world there. But if I go out of that one and say Python 3, and then now Python 3 is not defined, but Python is defined, well, I'm already on Python. So if I say print hello world here, and then just do that one, that would work. But notice if I just take the code out, since I'm inside Python 3, it will not work. It will just say syntax error. Did you mean Python 2 that syntax? And I say, yeah, that's what I meant, and it's gonna work. So when you're on Python 2.0, you can write a syntax like this, and it would work there. I believe earlier I showed you the Python 2 somewhere. Yeah, right here, Python 2. And when you get it to Python 2, it's there. So, and then here you could say for a statement for item and something like range of, let's say, 0,30, or let me just move this one up a little bit. So I'm gonna first of all clear my screen here. So I'm gonna say clear, and that would say for item and range of, let's say, 10, 100, and I'm gonna jump in 20 steps here and say print $ item. You can say, like, for example, something like this, and then you could get those numbers here. Notice that the range function, if I just use the same thing, and if I just jump in 30 right here, it's gonna go, the first one is 30, the next one is 40, and so on. So 30, and then right here, and then 10, 40, and 70, and then finish. So the 100 is not exclusive. When you do something like this, even if you print it out like one number, small, very jump 3, and then 3, and then you just do this, it's going to be 97, but 100 is not there. Sequence 100 is 100. Sorry, exit out of this one, and then now I'm on the bash. If I say sequence 10 and then 3 and then 100, actually let's do 20. 20, and now it's gonna just say 10 and then up to 19. But notice if I just change this one, the increment by 2-digit, it's gonna say 10, 12, 14, and 20 will be inclusive. So the sequence is a little bit different than the range function. First of all, the parameters, the way the step is on the sequence is second parameter, on range is third parameter, and also the range at the end is inclusive on sequence, but not on range. That's the difference. You have to pay a little bit attention to the details of that. Let's get to the next one. We did Python Interactive. Let's say Jupyter Lab. I'm going to do Jupyter Lab on this platform here, because when you run Jupyter Lab, it opens up browser, Jupyter Lab. If you install it, which Jupyter Lab, might not have installed the host name on MyWebUniversity. So let me do sudo apt install in Jupyter Lab. And then I'm going to type in my password. Jupyter Lab. Let me see what it is. Sudo. Maybe it is not an app, that maybe it's pep install. I have to do a pep install. Pep install Jupyter Lab. Yeah, there's a Python package that I'm installing it here. And once that one installed, Jupyter Lab will be installed, and then I could use it. But notice how many things are available with Jupyter Labs and Jupyter Notebook. So if I say which Jupyter Lab, Jupyter Dash Lab maybe. Yeah, Jupyter Dash Lab. So Jupyter Dash Lab. If you don't use it for a while, it's gonna just have that one. Now it opens up on port 888. You can see it's opening up a browser on localhost, and then now Jupyter Lab is here. And so on Jupyter Lab has a list of Python and Python 3, and then as well as terminal, as well as text file, macro, markdown, Python files. Each one of these ones, I have done a lot of demos on it. Please watch the details of the demo. But if you want to just write a Python program here, you get like a kind of cell, and you can start typing commands here. So if I just say aliases, and then just say run it, run the cell here, you will get a alias. Same thing like for item and a range of 10 numbers, and say print, let's say just item, whatever item plus item, we just add them up here, and we say run this cell. We point this one and we say run this cell, and it's gonna just say expected colon. So yeah, it is expected colon because right after the 10 here is a separator. You don't have a brace like programming languages, C, C++, but you need a colon here. So let me clear this one out, and then I'm gonna go here and then just type in that. Now we are going to run it, see if it fixed it. Yeah, it fixed it. So it adds up the number by itself. If you just want to multiply it, you could do multiplication and you could do addition and so on. There's a lot of these options that are available for you. You could do everything in terms of the interpreter. And if you just click on this tab, you say, go ahead, open the terminal. Now I'm inside that terminal. Since I'm on this machine, the Python version is telling me the version 3.10 is available, pip list. It shows all the modules that are available for me. I could do a lot of things. So I'm going to stop on the Python interactivity because I have made separate videos. I'm supposed to do only kind of like one-line commands here, like hello world, that thing, but I did a lot more. So let me just terminate this one. In order to terminate this one, you have to go under the file here and then say log out, and then shut down also under file. So if you did not shut down, you can close the browser and it will close this one, or you could just, since I don't need it, I could do a Control-C at this time, and then I'm not going to wait for it that long because I don't need this was for demo purpose, clearing the screen. So I'm going to show you a way that you can get another way that you can just look at it. So PS minus EF, grep minus I, Jupyter. If I'm just knowing that this Jupyter lab that I started, I need to kill this process, I could do a pkill in Jupyter lab and Jupyter dash lab. I could do that one, and then when I do this, PS, there's nothing. Or I could do a kill -9, the process ID of it. Either way, it's fine, and now that process is gone. So the one that I added was on this machine, I believe. Yeah, it was on this machine, and there's no process anymore. Grep minus I Jupyter. So I'm done with that one. Let's come back here when we go to compilers. On the compilers, we're going to show you C programming languages, C++, and a number of other ones. So we already covered the interpreter, which was this interpreter. And then on other ones, I'm going to have separate videos, but I'm going to do C, C++, maybe Go language, maybe Rust, maybe assembly. So let's do a number of them. First, we start with assembly language. So let's go to this. All I'm going to show you is that the host name here, MyWebUniversity, which is a Linux Ubuntu server. This one supports assembly programming also. The way you do it is say apt search NASM. NASM is the assembly language, programming language that you do. Man NASM will just tell you that it is the net-wide assembler, a portable x86 assembler. So you do have it, which NASM, which is when I installed it, all of this command, which LD, the loader for the linker stuff, it's all of them are available. So now I'm going to be on this directory. I go to NASM, and then on this one, and since I'm on this directory, I look at what files I have. I'm gonna remove hello.o, and that's it for deleting it, clearing the screen here. I'm gonna also remove hello.s. First, actually clear the screen. I don't need to delete that one because that's hello.asm. Sorry, clear the screen cat. Hello.asm. This is the assembly code that is there. But then at the same time, you have cat hello .s, which is that text portion of the file, and then I'm gonna just do the hello cat hello.compile. In order to compile it into an executable file, I need to do a number of things. First, I need to create from this assembly file an executable link format. And the way you do it is say nasm, which is that file, minus f elf, and then hello.asm. Now the file .object file got created. Hello.o got created, and it's executable link format because I put this elf syntax here. So the next thing that I need to do is that create an assembly object file with this hello.s as the actual source from that object file. So in order to do that one, you run the as -o hello.object and then hello.s. And that one will say that assembly message file and the file commented and file start. Now we have everything that it is ready for the loader to just run it. So loader is going to link it with the -s -o. The executable file is output file is hello, and then hello.o. Now I have a file called hello, which is notice that permissions are also set as executable link format 64-bit, and I'm going to run hello, and then that will just say hello. So we showed you how to just get a source code .assembly, how to create object file hello.output and hello.s. That we are going to use that one to just link them together and create a hello executable file and run that hello executable file. Okay, that was for assembly. Let's go to the thing. The next thing is C++. Let's get C++. Clear screen, CD to C. Here I have hello.c, cat hello.c, and as you can see, pound include the standard io.h and main. For all the standard io.h, iostream.h, I have also have on my website under the MyWebUniversity. If you go to this portion table of contents for the second page, which is this book that I wrote that is all online available. Chapter 9 is for C and C++ header files. So you can control F here and say include our standard io.h, and then you could just click on that one and you get the output of the standard io.h header files. And if you say, for example, I'm looking for a C++, a couple of thousands of these header files, I have put it in a nice format for you. So you can do control F and then say iostream. And then when iostream comes in, you just click on it and you read the iostream header file. So you don't need to just buy books on other ones. But at the same time, there's a lot of PDF files that I have shown you on my MyWebUniversity page, like under the PDF. So this is chapter 8 of that book, PDF. man_pdf, that will just give you all the 6,500 technical documentation here. So if you're looking for like a GCC, you click on this one, and then everything that is on GCC, there's a lot of them we're going to show here. The one that you're interested in, just look at that one and click on it. Like whatever is this one, you can click on it and you will get a graphic, PDF file for it. Okay. And then if you're looking for like Python, you could type in Python here, and then Python 3 shows up, Python 2, whatever is there, you could just read the PDF file. But let's come back to the C. On this one, I'm going to show you since we have the header files here, standard.io, and main, and then it says hello world, welcome to MyWebUniversity, and there's a return here. So I'm gonna say ls-l. In order to compile that program, this is a source file, hello.c. In order, it's not like a bash interpreter or Python that you run it one line at a time. Since the file has a few lines, hello.c, and up to 7 lines, you have to have this header files included, and then once you do this include, then you can use this printf function. And this int main is return integer, which is return 0 successfully, meaning that this is there. And this new line character is going to do that one. So in order to get this output, you have to say which GCC. GCC dash version is the C compiler, GNU C collection compiler. So that is the version that I have, 9.40. I say GCC -o hello, and then hello.c is the source code. Now I just created hello here. File hello, and then hello.c. Notice that hello is the source code, and then which is showing here source code ASCII text, but hello is executable link format that we created. So I'm going to run hello, and it's going to say welcome to mywebuniversity.com. And that's how that hello work program works. If I just look at the for demo, let's look at RM for a while demo, for example. I'm going to delete this one, while underscore demo 1. I'm going to say GCC -o while underscore demo 1, and then the source name is while underscore demo 1.c. Now I have a while demo 1.c, and then I say while underscore demo 1.c that just got created today with this timestamp, and then now it's going to do the while statement. Cat -n while underscore demo 1.c is going to then show that C. So there's other videos that I have made it. I'm not going to go too much detail on each one of them, so I'm going to jump in to C++ here. And then on C++, I have a lot of programs here. .c++ file star.c++, and then you could see that it is there, star.c++. So even or odd, let's do this one, even or odd.c++, cat -n even or odd.c++. And you can see that this program is going to do the IO stream because of C++, constant between int max 1 to 100, and it's going to use the scope resolution standard in. So I'm not using namespace. I'm using for cout and end of line std as the scope resolution, and then I'm going to just say let's compile it. So I'm going to say G++ dash version that is say this is the GNU C++ compiler. So in order to compile that code, the name of the file was this. I'm going to just say G++ -o even or odd. I'm going to make it a shorter name there. Now I've created that even or odd, and then that's the name of executable. So you can give it any name that you want, and it will say this one, file even or odd and .c++. That one says source code, but the executable is even or odd, and it will just tell me between all the numbers, the even numbers and the odd numbers. So that is for C++ code. Hello world and other things are similar. You just write a very short program to do hello world. And I think I already have hello.c++. So cat hello.c++ here. You can see that it is using namespace standard in, and we're doing that. So GCC minus O, actually G++ minus O, hello, and then hello.c++. Now I created file hello, and then that hello is going to just say hello world, welcome to my university, like it was. Okay, so that is for C++, and then let's go to Go language. Clear screen. Let's go to Rust first. Rust. Rust is I have one program, and then hello.rs is the name of the source. Very simple. This one does not have any header files. Very efficient, similar to Python, but the power of C and C++, the efficiency, much better than C++ even, because of memory leak and memory management is better in the Rust language. And then you can do concurrent programming and everything else. So you can also look at the Rust. So I'm going to say which rustc, that's the compiler. If it is installed on this one, I should have rustc here. If I don't have it, I have to get it on this other machine. But I think I don't have it because there's two things. When you do this one, you can say rustc hello.rust, and if you run it, it says there's no rustc here. So if I say rustc, it's going to say that it's not there. So I could do a sudo snap install rustc. Rust up. If I just do that one, it's gonna just say that this is revision is Rust up is published, but it is having some security risk. If you want to just do it, you can do it with taking the risk and use the -- classic. I'm not gonna do anything. You could do it at your local machine, and instead of doing it at the server side, or you could just do, and instead of snap, you could say apt install rustc, and that would install rustc. Then I will remove it after I demo this one. I don't need to have a compiler that I don't use on my machine that has some kind of warning. So here I have it now, which rustc, it is installed file rustc, it is clear screen, which rustc file user bin rustc, it is the executable link format for it, man rustc, it tells you that rustc is the Rust compiler. So this is already available on my system. That means I can just clear the screen and say rustc hello.rs, and then I just created the hello file. So rm hello, just to show you, now I don't have it, and then if I run rust c with hello, it will create that hello executable, and that would say hello world. And since the content of this file hello.rust is saying that, if I say file star, you can see that hello is executable link format, and the other one. So the Rust it was compiled on this x86. Uname minus uname -m for machine type, and uname -platform is x86. Uname -a gives you uname -a gives you all of the parameters. So we are in this one hostname CPL. You can see that it is on x86 architecture. It's Linux with this build version that is also showing here on the uname-r. That would be the same thing as here and there. So you get all that information what you're looking for. We cover Rust, and let's do another one. I'm going to go to Go language. Golang is there, and then clear screen cat hello.go. And notice that this is a simple hello world that Go program that I wrote. It has a package main. Notice all of these ones are lowercase, except the print, the methods that are used here. Go language is there. So if you didn't have the compilers, you have to do sudo apt install Golang. But if you already met the requirement, when you do this one, says requirements already met. So since I am going to say yes, go ahead, install it. Let's see what additional packages that are getting updated. Notice that Golang-doc is there, Golang is there, Go itself is there. So now clearing the screen, which Go language, it is there, file user bin Go compiler is this one. And then that's a symbolic link to that other one. So which Go lang, and that is not going to show, but then say apt list Golang with list that the Go language that is installed. And then Go doc FMT will give you on the FMT functions that are there for it. And so if I just say go doc fmt dot print line, then it will just show the print line function. So any of these FMT module that you have, like fscan, if I just know the syntax of the fscan, which is like similar to scanf on C and C++, you can do scan and then you will get the information on that. So that's how the Go help is there. But if you just say which Go, and Go itself dash help will give you all the parameters that how you could just compile the code, how to debug it, how to build it, how to list them, how to create modules, how to run it, how to get docs, and how to do additional help. And all of that is there. So in this case, I'm going to just say cat -n hello.go, and that one is just saying hello world. So if I say go run hello.go, it's going to just say hello world. Notice that you have to give the extension name, otherwise it's not going to understand it. So hello.go will run it, and then cat hello.go is this code. Okay, so that was for Go language. Let's see if there's anything else that I need to cover. Oh, Java. Java is another one that we could cover. Let me just clear the screen here. I'm going to jump into Java. Let's see what I have here. A host name. I don't have anything on the Java, maybe. Let me just see why. I should have had something. Okay, so I'm going to quickly check. Maybe I have it on the local machine on this one. So let's see, cd to programs. No, I must have had it on the Red Hat or Rocky. So I'm going to just on the machine that I am there, I'm going to quickly create a hello Word program on this one with Java. So I'm going to try to under the programs make there Java, cd to Java. And since I don't have anything here, let me see if I have something on the local machine here that I might have done it on the local machine. Yeah, Java is there. Yeah, I have a number of examples here on this one. So I'm gonna just show you how to just put it, populate everything, upload all of these files, dot class or the Java, and the dot Java, The executable link, it doesn't matter. So when you're in Java, like I'm on here, I could say if I have Java, I could compile it here. Java and then f dot class. If Java interpreter is there, it will do it. But I'm going to show you on the other server how we do it. So scopy -r start.java wp at www.mywebuniversity.com/home/wp/programs, and then I'm gonna push it into the Java directory, and then there's a secure copy. So I just copied all the Java files here from this one, clearing my screen here. All of this files, directory start.java, those 4 files or whatever number of files is. Now I should have it right here, and I do have all 4 of them. So since those are all the Java, if you look at it, even though the extension is .java and the source code is Java files, it says it's a C source code because there's a syntax like that one. So I'm gonna just do the hello first. Cat -m hello.java. And now you can see this has a class. Whatever's the name of the program, you just give it that name as that. And within the brace, you start the public static void main string args. And then the system.out print line is going to be the output that we want to print out, hello Java. So I'm going to now compile it, which Java C. And then if I don't have Java C on this one, I have to install it. So if I say Java C and then run the program hello.java, it's going to say, well, you don't have the Java C, but you have a choice of installing OpenJDK with apt install or other ones. So I'm going to say clear screen and say run this command here. And then since it prompts me here, I could say sudo apt install OpenJDK. And then the latest version of JDK that is showing here is going to try to do that one of JDK, Java Development Kit, JDK -11. Let me try the default JDK, default-JDK. And then I'm going to say yes. You can give it exactly the version that you want, it will find it there. And then now it's installing the default JDK and Java Development Kit or OpenJDK 11.0. As you can see, that package is part of the dependencies. So it will get installed there. And then Java, jar, Java C, all of them are going to be included within this OpenJDK or default JDK. The older version that we used to call it the standard Java Development Kit or runtime environment, it's also there, depending on what you want to do with Java. So and this is getting processed, and as soon as this one is processed, I will do this one. Unfortunately, I'm running out of time on just one video, but I will continue with this one. I will not stop here. It's going to be done soon. Okay, it looks like it's almost done. Yeah, it is done. So which Java C, which Java, which jar, all of those ones are there. So the related informations are there. This directory now, if I say apt list open JDK, then it's going to list if there is any packages. Listing done. I could also say list and grep -I JDK to see what is showing on the list of JDK. A lot of them open JDK-8 and all. So you have to give exact search name to get that list here. RPM -QA, grep -I, open JDK. You could do that one or do a JDK. It's not showing, but list was showing with the other one. So open JDK, open JDK, like that. It was showing, so you could get that list. And then if you want to do exact name here, you could do Debian package -L for listing, and you will get the list of files name with uppercase -L. At this time, I'm gonna do pwd ls-l cat hello.java. So I'm gonna compile that one with javac, and then I'm gonna say hello.java, and then now I have a hello.class file. So file hello.class is the executable of the bytecode, not executable. Compile Java class data file that you need a Java interpreter file, which the Java, and since I installed the Java user bin, and Java is the interpreter. Clear the screen. That is the interpreter for it, etc alternative. Then I'm going to say use the interpreter to run the hello dot class, and then that actually just run the hello, and it will just do that. And you don't give the dot class like Go language dot go. In this case, is hello is the executable. Hello dot class is the file name. So you just run it like that. Now cat -n f.java for the f statement. Let's do that one also. I'm gonna say javac f.java, and now we have a file called f.class as well as f.java file. f.star is going to say one is C++ source code with Java code, the other one is compiled Java class file. In order to run it, they say Java F, and then it will just say hello Java that many times. And if the number is equal 5, it says I love the number 5, which it does this. And right here, line 6 or 7, 5 and 6, it's comparison, the logic operator. The next one that I want to do is the for statement. So clear the screen, cat for .java file for.java, and now I'm going to just say Java C and then for.java. Notice the syntax of for statement is very much like C and C++. So you do have that option there. You learn it on one, and then you can do it on all of them. So now it is there. File for.class is the executable. The bytecode. I'm going to say now run it with Java virtual machine, the for, and it's going to just say hello Java 9 times because we said less than 10. So that is for the Java, and I hope you liked it, everything that we showed you today. And last but not least, I'm going to go back to the shell scripts, shells, and then clear screen, cd to loop, and cd to demos, and then I'm on this directory. There's a file called piece.sh, cat -n piece.sh. That's a shell script, about 27 lines, and then I'm going to run that one, piece.sh, It tells you basically thanks for watching or my YouTube channel, which is MyWebUniversity. And this is the handle, youtube.com/@MyWebUniversity. And then thanks for watching. Please make sure you like and subscribe our channel so we can make more videos. Peace to you all. God bless you. Take care. Have fun. Let me just go to my website, the YouTube channel. This is the YouTube channel. Please make sure that you subscribe and make comments and watch all these videos. It's more than 1,100 files or YouTube videos. Hope you enjoy it and learn from it. Take care. Bye-bye. Hi, everyone.